Wednesday morning. We start the final approach. Starting with trigonometry. Before we study the trigonometric functions, we need to study angles. A ray consists of one point on a line and all points extending in one direction from that. An angle is the union of two rays having a common endpoint called the vertex. Then the two rays are called the sides of the angle. So two examples here. Okay. And typically what we do, as you see on the one on the right, they put the angle there, or we can sometimes do this. Signify that as an angle. And angles generally are represented with Greek letters. So the most common one is the Greek letter theta. Create an angle, start with two rays. You pick one whole length ray. Fixed ray is the initial side. Rotated ray is the terminal side. So that means that an angle is measuring an amount of rotation. It's measuring the amount of rotation from the initial side to the terminal side. And there are two measures that we use. First is the degree. The degree is defined to be 1/360th of a circular rotation. The radian is defined as 180 over pi degrees. As with most things in math, how you set up the coordinate system doesn't matter. So typically speaking, how we draw the angle doesn't matter. The most convenient way to look at an angle is what's known as standard positioning. Angle is in standard position if its vertex is located at the origin and its initial side is the positive x-axis. If the rotation is counterclockwise, then the angle is positive. If the rotation is clockwise, the angle is negative. We set two angles to a terminal if they have the same terminal side when drawn in standard position. Reference angle. Angle's reference is the size of the smallest acute angle formed by the terminal side of the angle and the horizontal axis. Arc length is simply length of the curve along an arc. An arc length is typically represented with a lowercase s. So consider a circle of radius r. Length of the arc that is subtended by an angle theta is given by s equals r times theta. And it's very important to note that theta has to be measured in radians. There's a reason for that. Let's do some dimensional analysis. Unit analysis. So units of s would be a length, right? So centimeters, meters, feet, inches. The units for the radius are also a length, aren't they? So on the left-hand side, you're going to have length. The right-hand side, you have length times an angle. They don't match unless theta is in radians. Radians are actually a unitless measure. The radian is not actually a unit. So if we say pi over 2 radians, we really are just saying pi over 2. Now they match. Now you have a length equals a length. Whereas the degree is an actual unit. This is why most of our work with angles is done in the radian. Again, circle of radius r. Area of a sector subtended by an angle, once again, has to be measured in radians, given by a equals a half r squared theta. Start off by listing all angles coterminal to 40 degrees. This 40 degrees. So remember, coterminal, the angle has the same terminal side. That angle is the same terminal side, right? What's that angle? How do we get that angle? How'd you get 400? Then all we do is just rotate that ray 360 degrees, one full revolution of a circle. So why stop at one full revolution? I could do 2 full revolutions, right? And wind up at the same point, same terminal side. Or 8 full revolutions. Okay, that's going to be important. Isn't that angle also same terminal side? What is that angle? What is it? How did you get it? Still did one full revolution, right? But in the clockwise direction. But again, why stop at one full revolution? You do 16 full revolutions clockwise and it'd be the same terminal side. In either case, what are we doing to the angle? We're adding a full revolution. It's just in one direction or the other. So that means we're adding a multiple of 360 degrees, right? So that would be the list of all coterminal angles of 40 degrees. There's an infinite number of them. But they're all going to be of the form 40 degrees plus some multiple of 360 degrees. Coterminal of 2 pi over 3 is going to be the exact same argument, except now in radians. How many radians are in a full revolution? So 180 over pi is number of degrees in a single radian, right? So that's 1 radian. So use that. How many degrees are in a full revolution? What is it? 360, right? 2 pi radians are in 1 full revolution. The conversion factor, which was given in the definition, pi radians equal 180 degrees. So it's the same thing. It's going to be our angle plus any multiple of a full revolution. Full revolution is 2 pi radians, so it's going to be 2 pi over 3 plus 2n pi for any integer n. Right, so again, an infinite number of angles. Idea of coterminal angles are extremely important when we're looking at trig functions. Because typically with trig, we want to restrict our angles to 0 to 2 pi. So if you're given an angle outside of there, you just find the coterminal that's between 0 and 2 pi. Reference angles are also very important. Those 480 degrees. Remember what a reference angle is. It's the acute angle measured with respect to the horizontal, specifically the smallest, but it's kind of not really needed. Because you're only going to have one acute angle when measured with respect to the horizontal. And the reference angles typically represented with prime notation. So we call that theta prime. That is the angle we're looking for. Now the question is, how are we going to find it? We'll look at what we know. What's the measure of that orange angle? $180 degrees. So if we call that yellow theta, say, then what we would have to have is the sum of those two angles, yellow and red, has to be 180 degrees, right? Now we're looking for theta prime. So what does that mean, that theta prime? Would be 180 degrees minus that yellow angle. But what do we know about the yellow angle? How does it compare to the 480 degrees? How does it relate to the 480 degrees? Don't they share the same terminal side? Which means they're what? Two angles share the same terminal side. What do they call it? And what is it between? More specifically, it's actually between 0 and 180. But I'm not worried about that. I'm just going to keep between 0 and 360, so one full revolution of a circle. With that knowledge, what is theta? (120 degrees). Which would make our reference angle what? 60 degrees. The reference angle from negative 3 pi over 4. There's our angle negative 3 pi over 4. There's our reference angle that we want. Same kind of game. There's our coterminal angle theta, that's between 0 and 360, or in this case 0 and 2 pi. Again, stick that 180. In this case, notice what the relation is. Our coterminal angle would be 180 degrees plus the reference angle. If we rearrange that is what we wind up with. Right. The reference angle is coterminal minus 180. Or, I'm sorry, I don't want to use 180 degrees. We're in radians. So write it as pi radians instead of 180 degrees. So what is our coterminal angle? Answer this first then. How would you determine the coterminal angle? What would the process be? What would the process be to find the coterminal angle? We'll answer that one first. So you want the angle coterminal negative 3 pi over 4, so what would you do to determine that? What would you do with that ray? Which direction? counterclockwise, right? Clockwise would be going that way, which is the negative direction, right? You want to go the positive. So we take this ray, right? Do it right. And just rotate it. One full revolution. How many radians are in one full revolution? So what are you going to do to negative 3 pi over 4? Add 2 pi. What do you get? Negative 3 pi over 4 plus 2 pi. Since they both have pi, you can ignore it. Negative 3/4 plus 2. Look, there's your coterminal angle. 5 pi over 4. Now, what is 5 pi over 4 minus pi? That's your reference angle. So being able to do this process is extremely important. Also, doing the reverse process would be important. Like if I give you theta prime, being able to find what theta is something that will happen a lot in applications. Particularly in physics. So we're going to write 5 radians in degrees. What I'm do is multiply 5 by the conversion factor. That's what? 1 radian is how many degrees over pi? Five times 180. 5 times 18. And then times 10 would be 900. 5 radians is 900 over pi degrees. this notation. It's known as DMS notation. DMS is an acronym for degree, minutes, seconds. Degree, arc minute, arc second. Sorry, not 1/360th. 1/60th of a degree. Arc minute is 1/60th of a degree. These are 60 arc minutes in a single degree. An arc second is 1/60th of an arc minute. There are 60 arc seconds in one arc minute. So how many arc seconds would be in 1 degree? How many arc seconds in 1 degree? So how many seconds are in a minute?
60.
How many minutes in a degree? So you have 60 arc seconds in 1 degree. 3,600 arc seconds in a single degree. By the way, this is the exact same conversion as seconds, minutes, hours, where the degree would be an hour, so you can think of degree as an arc hour. The same exact concept. So if we want to write 424 degrees, 34 arc minutes, and 24 arc seconds into radians, First thing we need to do is just convert that to degrees. This one, I don't know if it's not. And so 34 arc minutes would be 34/60ths of a degree. 24 arc seconds. 24 3600ths of a degree. $31,843.75ths of a degree. Now the conversion factor. How many radians? I'm sorry, how many degrees would be in 1 radian? What is it? 180 is in pi radians. So how many radians in just 1 degree? You're overthinking it. Pi equals 180 degrees. What does 1 degree equal? How do you get 1 degree out of 180 degrees? Well, that's true. Think of degree as a variable. How would you solve for it? And so if you think of degree as a variable, call it x. Pi is 180x. What is x? One degree is pi over 180 radians. Conversion factor is pi over 180 degrees. Which is that ridiculous looking fraction. So 30 degrees in radians. Conversion factor. Thirty over 180 is what? It's the same as 3 over 18. Thirty degrees is pi over 6 radians. One 135 degrees, conversion factor, because we're still going degrees to radians, is pi over 180 degrees. I'm 35 divided by 180. What is it? Radians 3 pi over 4. 25 degrees, 30 arc minutes. So the arc minutes is actually half a degree, right? $25 plus a half. As an improper fraction. Wait, 25 times 2 plus 1. 51 hands. Then times pi over 180 degrees. Both 51 and 180 are divisible by 3. So 51 divided by 3. 17. What's 180 divided by 3? And of course times by 2. 17 is now prime, so we're done. 120 is not divisible by 17. 17 pi over 120. Twenty-four arc minutes, 24/60ths of a degree. 35 arc seconds is 35/3600ths of a degree. After those fractions, 6,107 over 144. Then times pi over 180 degrees. Sadly for you, 6107 and 180 have nothing in common. That doesn't simplify. Just 144 times 180. $25,920. You're probably going to want to make sure you have a calculator. $165.7 degrees. So this is where rounding rules are going to be necessary. $165.7 divided by 180. How many decimals do I want? How many digits am I going to want? So the rule with multiplying and dividing makes them do the same operation. The same number of significant figures as the smallest number of significant figures in your calculation. Well, the thing is, pi over 180 is a conversion factor. So we know it exactly. We're just looking at the 165.7. How many significant digits are there? What is it?
Wait, in 165?
165.7.
4.
There's 4 significant figures. We ignore the 180 because it's a conversion factor, pi over 180. So we know that exactly. So that 180 is actually 180.00000000000 infinite. So we want 4 significant figures. Is that leading 0 significant in the decimal? So you want 4 decimal places. 9205, what comes after this 5? This is where the rounding gets iffy. There were 2 main rules. First rule is the one that you're always taught. Look at the digit after. If it's 5 or above, you round up. 4 below, you keep. So by that, this would be 0.9206. Oh, that's not the rule that I used growing up. It would still look at the next digit, but it was then, if it was greater than 5, round up, lower than 5, keep the same. If it was exactly 5, you go out to the next digit and follow the same thing. Oh dear. Those are just 5s repeating. That's not good. So what would it round to? I'm just going to keep it as 0.9206. I can actually write that as a fraction, since the 5 repeats. But I'll save that for another time. .9206 pi. So that is the most common way to write it, is we just keep it in terms of pi. However, you could also approximate that further. So take that answer multiplied by pi. What is pi? Pi is an irrational number. So we actually don't know what its exact value is. Common approximation is 3.14. That's not good enough. 3.14159. That's about as far as I know. A friend of mine actually memorized 100 digits of pi. Never do that. As with the number e, you don't want to use the approximation. You don't want to use 3.14. So find wherever the pi button is on your calculator. Again, we want 4 sig figs. .892. Both of those answers will be acceptable. How many significant figures do we want? So what would it be with 3 sig figs?
0.0214.
0.0214. Right, those two leading zeros are not significant. Right, but remember that is if we're keeping it in terms of pi. If we're not, then just times that by pi. Negative 0.0672. And so again, either of those two answers would be acceptable. Let's go radians to degree. What's the conversion factor to go radians to degree? That's just 380 degrees over pi, right? Oh, well, 180 divided by 3. And pi over 3 is 60 degrees. Five pi over 9 times the 180 degrees over pi. 180 divided by 9 times 5. 5 pi over 9 is 100 degrees. Two-fifths of a radian. One 80 over 5. $36 times 2. $72 over pi degrees. 4/3 radians. That's 180 over 3 is 60. 60 times 4. 240 over pi degrees. Negative pi over 8. They are both divisible by 4 is 180 divisible by 8. It is not. We're going to be left with a 2. So just 180 divided by 4. That's just 180 divided by 2 divided by 2. 90 divided by 2. Negative 45 over 2 degrees. How many significant digits do we want? What is this, the 3 sig figs? $275.4 to 3 sig figs is what? 275. I mean, 275 over pi degrees, if you keep it in terms of pi. Otherwise, just divide by pi. Should be 87.7 degrees. Told the minute hand on the clock is 12 centimeters long. How far does the tip of the minute hand move during 20 minutes? represents 12, 3, 6, 9. What? 1, 2. And 11, something like that, but enough doesn't work. Send the circles like right there. Where the minute hand starts doesn't matter. What matters is it's going to go through 20 minutes. So let's just go with the standard. Let's start it at 12. And we know it's 12 centimeters. When it passes through 20 minutes, where does the minute hand end? On the 4, right? Means that's the length we're trying to find. Now we just need to know what's the angle. Well, there's 360 degrees, but I want radians. So there's 2 pi radians in the circle. And it's being divided up evenly by 12 units. 2 pi over 12 is what? 2 over 12? 1/6. Each tick represents pi over 6 radians. This would then be 4 pi over 6, which is 2 pi over 3, right? That angle represents 2 pi over 3 radians. Arc length, remember, was radius times angle in radians. What is the radius? The radius of our circle. What was it? 12 centimeters. That's what? 8 pi centimeters? Railroad curve being laid out on a circle. What radius should be used if the track is to change direction by 25 degrees in a distance of 120 meters? That is definitely not 25 degrees. represents the radius. So again, S is r theta. We know S, we know R, right? I'm sorry, we don't know R. We know S and we know theta. S is what? 120 meters? What's theta? True, but what does it have to be in? It has to be in radians. So you have to multiply 25 by pi over 180. $25 over 180. They're at the very least both divisible by 5. That'd be 5 over 36. 180 divided by 5. $120 times 36/5. Well, 120 is also divisible by 5. Right, that is what, 24? So 24 times 36. Should be 864. So the radius should be 864 over pi meters. So that's working with angles, which we'll be doing a lot of now. Monday we will start the trigonometric functions. We examine them in 2 ways, on a circle and on a right triangle. So that's Monday and Wednesday. So don't forget, there is that bonus opportunity for exam 1 that we'll do before Monday's class. Also, I am writing up a retake version of the first exam that will be posted on Blackboard. You retake and I'll take the higher grade. Once I have that finished, I will send out a message. It will be timed, 120 minutes, because you have to upload work, right, just like the quiz. I'm not sure on a due date yet, so I'll figure that out once I finish it. Now the message will come through Teams, so keep your eyes on Teams. Once that message goes out, the exam will be live. Microsoft Teams. It'll be like a direct message on Teams. Right. So if you have the app on your phone, you should get an alert on your phone, like when you get a text message when I send out.